So I don't know how Galen got me in the position of being at Meade, Nebraska, and introducing Terry Klopfenstein. And the worst thing about it was he didn't write a bio. So no one knows who you are. I'm in a room full of your former graduate students, and I'm supposed to introduce you. But
by the way, he didn't include a picture either, but I had to take one and I put it on there.
You had to take a picture of him. But so Terry, I'm not going to mess it up. Certainly an icon in the ruminant nutrition field, and I'm just going to turn it over to you. And be sure and turn in those evaluations.
Laser if you want. That's going to be real hard.
Got it. Thank you, Dan. Now, is that coming through?
Yeah.
Okay. Henry is back there. He's been mentioned before.
Just put it right here. You got a nice voice. We're going to hear it. There you go. Thank you.
That was a nice compliment. He said I had a nice voice. But I'd rather be singing, but that's beside the point. I won't do that to you today. So Henry's been heavily involved in this, and I appreciate his input. Do you get frustrated when you ask an expert a question and the answer is, well, you want an answer. You don't want it all depends, right? Am I right? Is that frustrating? Yeah. It's kind of frustrating when you're trying to answer that way too, which is what I'm up to today, right? But when you start talking about economics, that's really the case, isn't it? Well, it all depends, right, on so many factors. Now, of course, that's such an easy topic. When they were discussing topics for the program today, they said economics is so easy that Klopfenstein can do it, okay? So let's talk about some of those all depends. And it's been challenging, but a fun activity for me. So Galen went through these trials where 15 or 45% silage was fed, looking at silage as replacing some of that corn as an energy source, going back to high-priced corn, right? And thinking about that, to the Goodrich data, et cetera. This is a 4-trial summary, which starts getting some credibility, right, when it's repeatable. Now, what I've done is I adjusted the days to get the same ending weight, right? I just fed those 45% silage cattle a little longer because they didn't gain quite as rapidly. I want the same amount of gain for my economic analysis. And as he indicated, it's electronic, isn't it? Many of you know that electronics know when I'm around and they don't work well. So lower gain and poor feed efficiency. Okay, so whenever I'm talking about the 15 and 45, it's this summary. Okay? All right, let's go through the steps. This is fairly routine. Dan, I'm sure that's how you guys have gone about this in your pricing spreadsheet. Now, some points, though, that I think are important, that in Nebraska, a 10-year average, that the price of corn at harvest time, and then when you get to about this time of the year, when you're getting to the peak of the year of corn price, this is on average. It's not necessarily drought-based and things like that yet. When you're okay, That's 47 cents a bushel difference. We all know that. Corn goes up as we go through the year. That increase is roughly equivalent to storage cost. And that's logical, isn't it? It's got to be stored, so you really need to get more money for it, or you'd have sold it and fed it all up in the fall or something, right? Well, anyway, does that make sense? Okay, now, the next thing is that the basis in the fall at harvest time is about 39 cents a bushel. So, if I were going to price silage, and the way I've done it here in this calculation is to take what the futures market is for what we've got September and what is it, the next one? No, December for corn? Okay, they don't vary that much on long term. So if you take that price and then subtract out the basis, so what I was looking at about 6 weeks ago when I started working on these economics, I'm working at 343 cash price in the fall to base my silage price on. You with me? And the thought process is I'm pricing it in the fall because I'm not charging storage cost on the grain, okay? That balances out. Maybe that'll become clear. And then the harvest, hauling, drying, and small loss on the grain just turned out to be 47 cents. It's not related to that. They just happen to be the same. Okay, so what I'm doing is backing up this 343 a bushel that it's going to be, it was going to be in the fall when I started pricing this. It's the principle that's important, not the actual price. That gets it down to 296 in the field. So that's what I'm using to price the corn in the field. That's what we're going to pay for the silage, right? We've got to cover that cost of the corn. Okay, so I'm back to that net in the field. I'm using 225 bushel corn, irrigated corn. That comes out to be $666 an acre. That amount of corn is 5.32 tons. I didn't make this up. That's the way it calculates out. All right. I'm assuming that it's 50% grain at black layer. Jim went through some of those data, Fred Owens' data and so on. I think that's pretty close, Dan. If we just go with 50%, which means then that there would be that many tons of silage, right? Okay, but I'm harvesting at 38% moisture because Erickson told me that's the number, okay? You work with 38%, we just think that's going to be optimal, so that's what I used. Based on the data that Jim was showing, we're estimating a 6% yield drag at 38%. Okay, you with me? So it's 50% grain at black layer, at about 42 or 43. You back that off to 38, I've got a 6% yield drag. That gets me to 10 ton. That's why I'm saying I didn't just make this up to get an even 10 ton. All right, which means at 10 ton, that'd be 6660 or 2535 at 38% dry matter silage in the field. We together so far? Okay. Now, we've been charging for the plant nutrients that we remove when we harvest silage, the plant nutrients in the forage part. Right? When you buy corn for the feedlot, you're paying for plant nutrients, aren't you? because the farmer that raised the corn bought fertilizer, and that's part of his cost of production, and so you're paying for it. But on the silage part, we're taking off extra nutrients, and we've priced just the corn, okay? So we paid for those plant nutrients. So in the past, we've always added that cost in to what we've got to pay for the silage in the field. Now, the question is, and something that we had not considered before, is returning those nutrients. Well, that's kind of logical, right? You usually try to harvest silage as close to the feedlot for hauling purposes, as close as you can. And what do you do with manure? You try to haul it as close as possible to the feedlot. And you've taken more nutrients off of the field when you harvest silage than when you just harvest grain. So it makes sense to haul it back on the field, right? But we've not been considering that. I'm going to take you through that. Then there's the question of how much manure, and I'll get to that. Okay, so the question is how much manure? Galen indicated that, did he say 15 years ago? You notice the beard is getting kind of gray, right? So he's not a kid anymore. The experiment looking at zero, what was it? 15, 30, and 45, okay, percent silage. But our intent there was waste management. And the idea was, as we add fiber in the diet, they excrete more manure, it retains nitrogen better. That was our hypothesis, okay. The point is that we did it in our waste management pens where we could measure runoff, and we measured the amount of manure coming out, and so we did that over winter and summer trials. Okay, so this is nice because we've got the amount of manure that's produced, the amount of nitrogen that's volatilized off of that, and of course then the amount of phosphorus. Most of the phosphorus is in the manure. You get a little bit of runoff, 2, 3, 4% is all. The cattle don't retain a lot of the phosphorus that you've fed, okay? And in those trials, there was no distillers, okay? But so I've got that information to use for determining how much manure. Okay, so let's go through this. This is in that summary of those 4 trials. This is how much dry matter intake there was, feeding 45% silage. That's the organic matter. This is the amount of organic matter from the forage in the silage, okay? This is the amount of silage as 45% of that dry matter. Now, my number in parentheses then is tons. Now, this is the amount of manure out of that. And that manure is an average basis of 70%, about 70% moisture and 70% ash, right? About 30%, something like that, of organic matter. This is one of the issues with manure. We haul a lot of soil and so on. Okay. So 1.88 tons. Now, here in parentheses is the amount of manure, as is tons of manure, relative to a ton of 38% dry matter silage. Okay, so I'm trying to put this back on the as-is silage. 96 pounds of nitrogen excreted, roughly 50% is recovered. This is accounting for that retained in the animals. It's not what was fed, but what was fed minus what was retained. This is the phosphorus that's excreted, and you can see most of that then is in the manure. And these are the figures, the amounts. per ton of 38% dry matter silage. Now I want to get back to economics based on that. And what I've got in this column is looking at it plus or minus manure. And this is a distribution of manure, so we haul it once a year, okay? And we'll spend more time talking about that. Remember, we had it at $25.33 a ton out in the field. That cost of the nutrients that we remove from the forage portion of the silage at about current price of nitrogen and phosphorus. We're ignoring, did I say phosphorus? Yeah, phosphorus. We're ignoring potassium because our soils have enough potassium. So in Nebraska, we've just kind of been ignoring the potassium. So I'm pricing nitrogen and phosphorus. So it's $1.93 as is ton. Okay, that I'm the cattle feeder. I've got to pay the farmer for silage. Okay? Wow, that's a big number, isn't it? The thing is, I'm going to haul $14.53 of nutrients back to that field per ton of silage. Where'd all those nutrients come from? Some from the silage, but a lot of it came from the 40% distillers that's in the diet, right? A lot of nitrogen and a lot of phosphorus. From the standpoint of using the silage, I'm going to take those nutrients and give it to the silage. That's what I'm doing here, okay? So you can see that's a big number. I'm to the point, I think the farmer should give us the silage just to have the manure. I'm joking, okay? Do I show my bias? Students, what's my middle name? Cheap, right? So I'm trying to get this silage as cheap as I can. Anyway, all right. So net in the field would be $12.73 and $23.63. Over in this case, I'm having to pay $1.93, and this is the value of the nutrients that are in all of the silage. Is this complex? Let me try this again. This is the nutrients I'm removing in the forage portion only. This is the nutrients that's in the silage that I can replace every year. Okay? So it's what's in the grain part. But remember, I don't have to pay the farmer for that because he was already compensated for that in the corn price. All right, so I'm net in the field. These two numbers, it cost me $2 per, this is per ton of the wet silage, 38% dry matter silage. It cost me $2 per ton to spread that manure. Okay, so I got credit for that whole bunch of manure, nutrients, but I had to haul it out. It's costing me 50 cents here because I'm hauling it only 1 year and 4. Okay? We've got people here that will have different numbers, but I'm charging 11 per as-is ton to haul, harvest, haul, and pack. That's based on the data that our Ag Econ department puts out where they look at rental rates. I'm not pulling it out of the air. Storage. Casey, did you do the high moisture corn storage cost? Yeah. Actually, it's interesting that when we started looking at the figures, you get about as much as is weight per cubic foot of silage as you do high moisture corn. Well, you're thinking, well, yeah, you get how much your corn's a lot more dense. But remember, it's got a lot less water. So if you're talking about as is tons of silage, you get so I just used your figure. I know that's risky, but I used your figure. All right. $2 for the storage. I'm in a bunker silo, okay? So my net price to the feed yard, $27.73 versus $37.13. All right. Next slide. Okay, I'm taking those numbers, and if I look at 10 or 15% shrink, Keith, I'm still hoping we can get within that range at least. If we're doing a good job of packing and we've got a decent size, so we were discussing this over lunch. I want a real tall silo because you've got less surface area the bigger you get it, and he doesn't want it that tall because he's afraid he's going to be sampling it and it's going to fall on him, right? I'm kind of joking, but that's what we're faced with, is some of the things that don't work together. Anyway, so much for that. Okay, so at 10% shrink, that silage is $30.81 a ton. This is the interesting number. Now, I've tried to put this all on a percent of corn basis. Okay? So that's 52% the price of corn. That's pretty cheap, right? At a 15% shrink, it's 55%. Okay, what I've done down here then is if I don't account for any manure value, that's the way we've tended to do it in the past. We've ignored hauling manure back out there. Okay, then I've got 76 to 80.4%. So is the manure a big deal? Now over here, where I'm hauling manure 1 year out of 4, and I'll get to this more, it's 70 and 74. Those are pretty good numbers. My guess is most of you are saying, well, that can't possibly be true, right? It can't be that cheap. But that's what the numbers have said thus far. We can talk about it. All right. This is the way I've looked at the economics. So you're saying, well, you're jumping around. You used 343, I think was the number I used for pricing the corn in the field. Now I'm at 367. What did I do? I added 24 cents because remember that the price of corn changes over the year by 47 cents a bushel, right? I have that because the corn that you feed in the feedlot is going to be the average for the year. So it's 24 cents on top of the 343. That's $155 a ton of dry matter, okay? The diet cost is $150 a ton when I'm using 15% silage, like Dan and others were talking, using it as the roughage source. That comes out to $2 a day for the cattle on that 4 trial summary. I'm using 55 cents a day for interest and yardage, about 15 cents for interest and 40 cents for yardage. Again, you can debate whether that I need to do that because remember, I'm feeding more days at 45% silage, so I've got to account for that. That cost is $347 to put on the 537 pounds of gain. What I did then with the 45% silage diet, I just back calculated what I could pay for the silage to break even. I could pay $124 per ton of dry matter. That's 47 per ton at 38% dry matter. Right at 80% the price of corn. Right? This is roughly 80% of 155. You with me? Okay, the 80 is the number that you should have in your head. Not that that's the magic number, but I think you'd have a tough time convincing me that that's really wrong, how I've done my calculation here. Okay, some of the other assumptions you might argue with. But but the 80% is a good number for you to have in your head as we discuss the rest of the economics. That's our target. If the silage is costing us less than 80% the price of corn, it'll make us money. If it's costing more than that, it's not going to make us money. You see, my reference point is 80%. Now, the manure seemed like a really big deal, and I think it is a big deal that we've not thought about in the past. What's the problem? The problem's all that phosphorus from the distiller's grains, right? We know that that's our manure issue, and it's a distribution issue. I look at 4 ways that we can accommodate that. We can rotate silage fields so that we only cut silage every 4th year, and then we can haul all of that manure back on that field, and we can get our silage cost is really low. That really fits, if you can do it. Now, that may mean that you're having to haul silage greater distance. I don't know how to account, I don't know how to do that, because I don't know what that distance might be, etc. That would, each situation would be different. I just don't know how realistic that is for the farmer and the feedlot. This is the one that I was showing on the right-hand column, and that's where you would spread manure 1 year in 4 to only replace the removal of phosphorus in the silage. I went through that with you. Remember, we're paying the farmer for the phosphorus and nitrogen in the forage part of the silage. But what we can return to the field, because we took the grain off in the silage as well, we can return all of those nutrients that the silage took off. That's what I'm proposing to do here. And Galen pointed out to me, and Andrea, that if I tried to haul 1/4 of the manure each year, your spreading cost eats you up, and it becomes a break even. That's what I've done down here. If every year I just haul enough phosphorus out to replace that in the corn silage, it gets too expensive. So it costs me as much to haul it as the value of the phosphorus and nitrogen are. I'm talking phosphorus because that limits how much we can haul. But the value is the combination of the phosphorus and the nitrogen. So this is just the same as if we weren't crediting the manure at all, that 76 to 80.4%. Again, to me, this is quite realistic. You would just haul the manure 1 year in 4. The other 3 years you would not haul manure on those fields because it's got all the phosphorus that you can haul to it. Remember, up here you could rotate fields. That looks interesting, doesn't it? If you're cheap, that looks interesting. Okay, back to finish your, this is the same slide, and so I wanted to point out, thinking of the 80% is of the break even. You can see how much better this looks without considering the manure. That's what these are down here. you got to keep that shrink down, Keith, for it to pay. I think this looks really intriguing. Okay, I think that's very doable. Interesting. You understand what we're talking about, though? We're talking about feeding higher levels of silage to replace corn in the diet as an energy source. We're not talking about just using it as a roughage source. Dan, is what has been very traditional. Growing diet. Henry has conducted an experiment this last winter, and I'm using those data from his control. It's not published yet. In this case, they ate 1,611 pounds of dry matter. That's the organic matter intake. Now, the forage part of the silage is greater now because we're talking about a diet that is 80% corn silage, 15% distillers, and then a 5% supplement that's got minerals, vitamins, and a corn carrier. In this case, the silage dry matter is a much higher proportion. It's 80% of that diet. It's 0.644 tons. Manure is less, a shorter feeding period. And remember now, we're not getting all the manure from the other components in the diet. It's mostly from the silage. Okay, coming down here, nitrogen excreted is 27 pounds. Half of that is volatilized. 4.4 pounds of phosphorus, 4.2 in the manure. And so 2.5 and 8 per ton of 38% dry matter silage. And that's just about what came off in the silage. So in that case, if we haul this manure back to the field, we're essentially replacing those nutrients that came off when we harvested the silage. Is that clear? Okay. So we can take that credit. It's very much, I don't think I've got that. Well, I do have it. Okay, so this is the economics. Again, back to my 25.33 in the field. What we're having to pay for those nutrients in the forage portion of the silage. This is manure fertilizer credit. That's the net price in the field. My spreading cost, again, the 11 and 2 is the same. So the net price is $37.62 to the feed yard. At 10% shrink, that's 71% the price of corn. And at 15%, that's 75%. So we're staying under the price of corn on both of these. Again, I want to reemphasize, look what's happening here. If you subtract this from this, what is that, 2.5 or something like that? It's a little more than this. So at least we're covering that. You with me? We're at least covering what we've been charged in the past for taking those nutrients off. That helps us in this relationship. The trouble is, in the finishing work, we've got that control diet that's 15% silage to supply roughage. We've got that as a standard to compare the 45% silage to, okay? That's what I've done. That's where I got the 80% the value. 80% is break even, right? Not of the value, 80% to break even. Well, I don't have that kind of a control on the grower diet. And so what I've done is what Galen promised I would show. I'll get to that next slide. It was 275 pounds a gain. This is what they ate. The diet cost at 10% shrink was $119 a ton. And then the diet plus yardage plus interest was $137.80. That's a cost of gain of 50 cents a pound. That includes interest and yardage, remember. That's not feed cost. That's 50 cents a pound. If it's 15% shrink, it jumps way up to 52 cents a pound. That's not a bad cost of gain, is it? Now, that's a little misleading because younger growing cattle are more efficient than 1,400 pounders, right? But that's still a pretty good cost of gain. Now, if my next slide is the correct one, what I've done here is look at the cost per unit of TDN in grower situations. At 10% loss of the silage, 7.75 cents per pound of TDN. 15, it goes up a little bit, as you would expect, to 8.2 cents. Corn grain, at that 367 a bushel that I was using, 155 a ton, dry matter, is 9.35 cents a pound. So this silage is cheaper per unit of TDN. Okay, those are direct comparisons now. We're not talking about the 80% because I've adjusted it to the amount of TDN that we believe is true in a grower diet. Distillers, I just priced the distillers equal per ton of dry matter to corn. You can debate, you may be getting it less than that, you may be paying a little bit more today, I don't know. I priced it equal to the price of corn. And let me reiterate, this is a grower diet. Erickson keeps saying that distillers grains has more energy than corn in a finisher, right? You've heard, and he says wetter is better. That doesn't work in growers. They're all the same. And the data would say it's 136 to 137% the value of corn in a grower in a forage-based diet. We're using 100, I used 130 here. I was trying to be conservative. Okay, once you do that, you can see what the effect of that has compared to corn. So what's our cheapest source of energy in this grower diet? Distillers grains, right? Hay at 70 a ton, that may be too cheap, is even above the silage, and it's up at corn if it's $80 a ton, because I'm having to grind that and have some loss in grinding and so on. Okay. So, what makes sense here for a grower? Corn, silage, and distillers grains, right? Those are the two inexpensive sources per unit of TDN. So, the manure value is important. Galen, I think we've missed this up until now. We've not, all the manure work we've done, but have not put it together with this whole silage thing. And it makes sense to get manure back on silage fields, right? Again, they may be the close fields to the feedlot. The limitation is just how much phosphorus you can haul, and I've gone through that with you. The other point is that obviously shrink's important. We've had just excellent discussion today about shrink and how to control that and so on. Critically important. Boy, silage looks economical in grower diets to me. That slide about the cost per unit of TDN, Seems clear cut. What's nice is that it fits with the distillers, which is also inexpensive. Somebody today talked about protein and the value of protein, and so Andrea did a nice job of explaining how the distillers then. So I just priced it per unit of energy, right? And you get that protein in the distillers along with it. So distillers grains, whatever, 20%. She had some numbers, I forgot which they were in that 20%. Excellent gains. Okay, enough said about that. In finisher diets, Keith, if it's well managed, if we keep the shrink down, if we're working on this, I think on the manure credit, this idea that I doubt our panel didn't say anything about higher levels in finishing diets. I think there's real potential for that, but it's really got to be managed. Kai and Eric, yeah, there's potential there. What we don't know are all of the ratios, Galen kind of alluded to that, all of the ratios of distillers to corn silage. Most of the work has been at 40% distillers and 45% silage. Yeah, but we may want to feed a little less distillers. So what are the right ratios? Another thing that is of interest is the idea of two-phase. What did I say? It really works as a grower, right? So maybe we grow them. If you go back to Dick Goodrich, that was his concept, right? Was you grow them on silage and then you finish them. That also would potentially get us away from the feed efficiency thing. You're not as concerned about feed efficiency on a grower situation. The cattle are finished then, and anyway, so much for that. Could use a lot more silage. And I think I accomplished my objective of trying to make it reasonably cheap, okay? With that, I'd be happy to have some discussion.
So on 225 bushel corn yield, what are you expecting for a silage yield?
Terry, repeat the question,
Yeah,
please.
the question was 225 bushel corn yield. What am I expecting for silage yield? Okay, that calculated out to be 10 tons of dry matter. Okay, it was 10.32 or something like that of, and then I had the yield drag at 38% moisture. Okay, if you remember that slide. So it was 10 tons of dry matter. You divide that by 0.38, which is the dry matter content that I'm harvesting at, and then that gives that yield. I don't remember what the number was, but it's 25 ton or something. You with me?
Yep.
How much?
27 tons.
27 tons. Okay. You see, I'm mostly interested in the logic of how to go through that, but it gives you an idea of what kind of yields that you would expect in that kind of a situation. Yeah. Okay, other questions?
Other questions for Terry? Let's thank him again. So I think Galen's got a